Welcome friends. Today we'll be discussing about Gibbs free energy change and standard Gibbs free energy change. So let's begin with the introduction. Gibbs free energy. Gibbs free energy is also known as Gibbs function, Gibbs energy, or free enthalpy. It is the quantity used to measure the maximum amount of work done in a thermodynamic system when the temperature and pressure are kept constant. It is denoted by symbol G. Its value is usually expressed in joules or kilojoules. Gibbs free energy can be defined as the amount of energy available from the system that can be converted into useful work. The equation for Gibbs free energy is G is equal to H minus T into S, where G is the Gibbs free energy, H is the enthalpy, T is the temperature, and S is the entropy. So next is Gibbs free energy change, which is denoted by delta G. It is the maximum amount of non-expansion work that is extracted from a thermodynamically closed system and can be attained only in a complete reversible process. It is the energy associated with a chemical reaction that is utilized to do work. So the formula for Gibbs free energy change is delta G is equal to delta H minus delta T into S. If the reaction is carried out at constant temperature where T is equal to 0, then the above equation can be written as delta G is equal to delta H minus T delta S. This equation is called as Gibbs-Helmholtz equation. Delta G can predict the direction of the chemical reaction under two conditions. First condition is constant temperature and the second condition is constant pressure. If the value of Gibbs free energy change is less than 0, the reaction is spontaneous, that is, the reaction is exergonic. If the value of delta G is equal to 0, the system is at equilibrium and there is no net change in the forward or backward direction. If the value of delta G is greater than 0, the reaction is not spontaneous and the process proceeds spontaneously in the reverse direction. To drive such a reaction, we need to have an input of free energy, that is, the reaction is endergonic. Delta G depends upon the difference in free energy of products and reactants. It is independent of the path of transformation. Now let us see what are exergonic reactions. These are the reactions in which the value of Gibbs free energy change is negative, that is, it is less than 0. These reactions release energy in the surrounding and they are spontaneous. The chemical bonds that are formed from the reaction are stronger than the bonds which broke from the reactants. Examples are combustion, chemiluminescence, mixing of sodium and chloride to make table salt. Endergonic reactions. These are the reactions in which the value of delta G is positive and these reactions absorb energy from the surrounding. These reactions are non-spontaneous and the chemical bonds that are formed from the reaction are weaker than the chemical bonds that are broken from the reactants. Example is photosynthesis and melting of ice into water. Next is standard free energy change, that is delta G naught. The standard state free energy of reaction delta G naught is defined as the free energy of reaction at standard state conditions. So the formula is same as delta Gibbs free energy change, but the only difference is here the values are in their standard state. So the formula is delta G naught is equal to delta H naught minus T delta S naught. If delta H is greater than T delta S, the reaction is enthalpy driven, and if the value of delta H is less than T delta S, the reaction is entropy driven. For a spontaneous chemical reaction, delta G naught is negative, and for that the value of delta H naught should be negative and the value of T delta S should be positive. For a non-spontaneous reaction, the value of delta G naught is positive, and for that the value of delta H naught should be positive and the value of T delta S naught should be negative. Standard state free energy of formation. The standard state free energy of formation is the change in free energy that occurs when a compound is formed from its elements in their most thermodynamically stable states at standard conditions. In other words, it is the difference between the free energy of a substance and the free energy of its constituent elements at standard state conditions. So the formula of standard state free energy of formation is delta G naught F of products minus delta G naught F of reactants. All elements in their standard states, elements like diatomic oxygen gas, graphite, etc., have standard state free energy change of formation equal to 0. That is their value of delta G naught F is 0, as there is no change involved. So there are some problems related to Gibbs free energy change and standard Gibbs free energy change. Let's solve the first problem. The standard Gibbs free energy change for a reaction at an absolute temperature T is given by delta G naught is equal to A minus B into T, where A and B are non-zero constants. Choose the correct statement about their reaction. So we are given 4 options. Let's see the correct answer. So the correct answer is D. The reaction is endothermic if A is greater than 0. Let's see how we get the answer. So we use the formula delta G is equal to delta H minus T delta S. And if we compare this equation with the equation given in the question, we can say that the value of delta H is equal to A and the value of delta S is equal to B, and T is the temperature. So when the value of delta H is positive, that is when the value of delta H is greater than 0, the reaction is endothermic, that is it requires energy to proceed. Second question, find out whether the reaction is spontaneous or not at 127 degrees Celsius. So we are given the reaction and the value of delta H and delta S is also given to us. That is, the value of delta H is 92.22 kilojoules per mole and the value of delta S is minus 198.75 joules per Kelvin per mole. So we have to check whether the reaction is spontaneous or not. Let's see the answer. So the answer is B, that is the reaction is not spontaneous. So in this question, we use the same formula as the first one, that is delta G is equal to delta H minus T delta S. So by substituting the value of delta H as 92.22 kilojoules per mole and the value of delta S as minus 198.75 joules per Kelvin per mole, we get the value of delta G, that is Gibbs free energy change, as 171.72 kilojoules per mole. So because the value of Gibbs free energy change, that is delta G, is positive, the reaction is non-spontaneous. That is, it is an endothermic reaction and it requires energy to proceed. The third question is, the melting of ice into liquid water is an example of dash reaction. Question 4. Which of the following is not a type of exergonic reaction? Formation of table salt from sodium chloride, combustion reaction, C. chemiluminescence, or D. photosynthesis. Let's see the answer. So the answer is D, that is photosynthesis. So a reaction that is spontaneous and favorable is known as exergonic reaction. It releases energy into the surrounding. The system's free energy decreases here. The Gibbs free energy of an exergonic reaction is negative. The last and the fifth question is, calculate the standard Gibbs free energy change from the free energies of formation. So the reaction is given to us, and the value of delta G naught F of the reactants and the product is given. So the correct answer is C, that is 3225 kilojoules per mole. So we use the formula delta G naught is equal to delta Gf of products minus delta Gf of reactants. So when we substitute the values of products and the reactants which are given to us, when we substitute these formulas in the equation, we get the value of delta G naught as 3225 kilojoules per mole. The sum of the references. Thank you.